Let me tell you about something that NASA has never fully explained, something that was present on the lunar surface before Neil Armstrong took his first step, something that the Apollo astronauts observed and reported, something that challenges our assumptions about what awaited humanity when we first reached another world. The astronauts saw it. This is not conspiracy theory. This is not fabrication. This is documented in mission transcripts, captured in photographs, recorded in debriefing reports. When Apollo 11 landed on the Sea of Tranquility on the 20th of July, 1969, the astronauts encountered phenomena. They were not prepared for phenomena that remain inadequately explained more than half a century later. I want to be clear about what I am and am not claiming. I am not suggesting that aliens were waiting on the moon. I am not proposing that NASA discovered extraterrestrial artifacts and covered them up. The reality is stranger and more interesting than simple conspiracy narratives. It is a story about the unexpected complexity of what we thought was a dead world, about phenomena that our models did not predict, and about the limits of our understanding, even of our nearest celestial neighbor. What the astronauts saw challenges our assumptions in profound ways. It tells us that the moon is not the static, unchanging world we imagined. It suggests that processes are occurring there that we do not fully understand. And it raises questions about what else might be waiting for us as we return to the lunar surface with the Artemis program. Let me take you through what the astronauts actually encountered, because understanding it requires examining the evidence carefully, separating fact from speculation, and confronting the genuinely mysterious aspects of our nearest neighbor in space. Let me start with what was known about the moon before Apollo. Before humans landed on the moon, we had studied it for centuries with telescopes and for decades with robotic spacecraft. We thought we understood it well. We were wrong. The moon appeared to be geologically dead, a world that had ceased volcanic activity billions of years ago, that experienced no weather, no erosion, no change except the slow accumulation of meteorite impacts. The surface was expected to be static, unchanging on human timescales. The moon was known to be airless, a perfect vacuum at the surface, with no atmosphere to scatter light or carry sound. The sky from the lunar surface would be black even in daytime, with stars visible alongside the Sunday. The moon was understood to be dry, completely devoid of water, baked by unfiltered solar radiation for billions of years. Any volatile materials that might have existed early in its history would have long since escaped to space. The moon was believed to be silent in the electromagnetic sense as well as the acoustic. With no atmosphere and no geological activity, it should produce no signals, no emissions, no phenomena beyond the passive reflection of sunlight. These expectations shaped the Apollo missions. The astronauts were trained to explore a dead world, to collect rocks from a frozen landscape, to document a place where nothing happened. They were scientists and pilots, not investigators of anomalies. But the moon they encountered was not entirely the moon they expected. Now let me describe what the astronauts saw before landing. As the Apollo 11 lunar module Eagle descended toward the Sea of Tranquility, Neil Armstrong and Buzz Aldrin were focused on finding a safe landing site. The automated guidance system was taking them toward a boulder field that Armstrong judged too dangerous. He took manual control and flew the spacecraft horizontally, searching for clear terrain while fuel ran critically low. This dramatic landing is well known. What is less known is what the astronauts observed during their approach, observations that appear in mission transcripts but are rarely discussed. During the descent, both astronauts reported seeing flashes of light on the lunar surface. These were brief, transient events, points of light that appeared and disappeared quickly. At the time, they attributed these to reflections from spacecraft surfaces or optical artifacts, but the observations were noted. and they were not unique to Apollo 11. The phenomenon of lunar flashes has a long history. For centuries, astronomers on Earth have reported seeing brief brightenings on the moon events called transient lunar phenomena, or TLPs. These reports were often dismissed as observational errors or atmospheric effects. But the Apollo astronauts, observing from space with no atmosphere to confuse their observations, saw them too. What causes these flashes? We still do not know with certainty. Possible explanations include meteorite impacts, which would produce brief flashes of light as kinetic energy is converted to heat. Outgassing events, where gases trapped beneath the surface are released, could potentially produce luminous effects. Electrostatic discharges caused by the charging of lunar dust in the harsh radiation environment might generate visible light. Each explanation is plausible. None has been definitively confirmed. The flashes remain a genuine mystery, a phenomenon that occurs on a world we thought was completely inert. Now let me describe what Armstrong and Aldrin saw on the surface. After landing, before the first moonwalk, the astronauts had several hours to observe their surroundings through the lunar module windows. What they saw was strange. The lighting was unusual. Shadows on the moon are absolute, with no atmosphere to scatter light. Shadows should be completely black, but the astronauts reported that shadows were not entirely dark. There was illumination within them, a faint glow that softened the expected harsh contrast. This was not impossible to explain. Light reflected from the lunar surface and from the astronaut suits could partially illuminate shadowed areas. But the effect was stronger than expected. The moon's surface seemed to glow faintly, to possess a luminosity that simple reflection did not fully account for. The horizon was strange. The moon is much smaller than Earth, so the horizon is closer and curves more noticeably. The astronauts commented on how near the horizon appeared, how sharply the ground dropped away. But they also noted a peculiar haziness at the horizon, a glow that extended above the surface, visible, especially when looking toward the sun. This horizon glow became one of the most intriguing observations of the Apollo program. It was photographed multiple times by multiple missions, and it should not have existed. On an airless world, there should be nothing above the surface to scatter light. No atmosphere means no sky glow, no haze, no gradual transition from surface to space. The boundary should be sharp ground below, black space above. But the astronauts saw something else. They saw a glow extending above the horizon, following the curve of the moon, present on the day side and extending into the darkness of the night side. Something was there, suspended above the surface, catching and scattering sunlight. Now let me examine the horizon glow more carefully. The horizon glow photographed by Apollo astronauts, particularly the famous images taken by astronauts looking out over the lunar surface at dawn, has been studied extensively since the missions. The glow appears as a distinct brightening along the horizon, extending several degrees above the surface, visible against the blackness of space. What could cause this? The leading explanation is levitating lunar dust. The lunar surface is covered with a fine layer of dust, the regolith ground from billions of years of meteorite impacts. This dust has unusual properties. It is electrostatically charged by the solar wind and by ultraviolet radiation from the sunday. The particles carry electrical charges that can cause them to repel each other. Theoretical models suggest that near the terminator, the boundary between lunar day and night electric fields could become strong enough to levitate dust particles above the surface. As the sun rises or sets, the changing illumination creates charge differences that could launch dust to significant heights. If dust is indeed levitating above the lunar surface, it could scatter sunlight and produce the observed horizon glow. The phenomenon would be most visible at dawn and dusk, when the sun is near the horizon and the geometry is favorable for seeing scattered light against the dark sky. This explanation is plausible and has become the accepted scientific consensus, but it has not been definitively proven. The predicted electric fields have not been directly measured. The levitating dust has not been directly imaged. The horizon glow remains, in some sense, an explanation awaiting confirmation. And there are aspects of the observations that the dust hypothesis does not fully explain. Some astronauts reported seeing distinct rays of light extending above the horizon, streamers that seem to have structure rather than the diffuse glow that simple dust scattering would produce. These streamers were reminiscent of crepuscular rays on Earth, the sunbeams that appear when light shines through gaps in clouds, but the moon has no clouds. What could produce structured light rays on an airless world? The question remains open. Now let me describe what the astronauts found when they stepped outside. When Neil Armstrong descended the ladder of the lunar module and placed his boot on the lunar surface, he made observations that have become iconic. The surface is fine and powdery. I can kick it up loosely with my toe. It adheres in fine layers, like powdered charcoal, to the sole and sides of my boots. This dust, the lunar regolith, turned out to be stranger than anyone expected. First, it was incredibly adhesive. The fine particles clung to everything, to suits, to equipment, to the lunar module itself. The astronauts found it almost impossible to keep the dust off their gear. It worked its way into seams and mechanisms, coating surfaces and degrading equipment. This adhesiveness was partly due to electrostatic charge, as the dust particles carried electrical charges that made them stick to surfaces. But there was more to it. The dust particles were jagged and sharp, not rounded like earth sand. Without wind or water to erode them, the particles retained the sharp edges created by micrometeorite impacts. These jagged particles interlocked and adhered mechanically as well as electrostatically. Second, the dust smelled strange. When the astronauts returned to the lunar module and removed their helmets, they noticed a distinct odor clinging to their suits and equipment. Armstrong described it as wet ashes in a fireplace. Aldrin called it the smell of spent gunpowder. This smell was unexpected. The moon was supposed to be chemically inert dead minerals that had been exposed to vacuum for billions of years. What chemical process could produce a noticeable odor? The leading explanation involves the highly reactive nature of freshly exposed lunar dust. In the vacuum of space, the outer surface of dust particles becomes activated. Atoms on the surface have unsatisfied chemical bonds, making them reactive. When the dust was brought into the oxygen-rich atmosphere of the lunar module, these activated surfaces reacted with oxygen and moisture, producing volatile compounds that the astronauts could smell. This explanation is plausible, but it reveals something important. The lunar surface is not chemically dead. It is reactive, dynamic in its chemistry, capable of producing unexpected effects when its isolation is disturbed. Third, the dust glowed. Some Apollo astronauts reported that lunar dust seemed to glow faintly in darkness, a phenomenon distinct from the horizon glow observed on dust coating their equipment. This luminescence, if real, would be difficult to explain by any conventional mechanism. The reports are ambiguous. Lighting conditions in the lunar module were challenging, and distinguishing genuine luminescence from reflected light or visual artifacts is difficult. But the observations were made, and they remain in the record. Now let me discuss the unexplained lights. Throughout the Apollo program, astronauts reported seeing unexplained lights on the lunar surface, points of illumination that appeared where no illumination should exist. During Apollo 11, Armstrong and Aldrin reported seeing a light in a crater during their approach. The light was brief and they did not have time to investigate, but both astronauts noted it. During Apollo 12, astronauts Charles Conrad and Alan Bean observed what they described as a point of light on the lunar surface while in orbit. The light appeared and disappeared over a period of minutes. They reported it to Mission Control, which had no explanation. During Apollo 14, astronauts Alan Shepard and Edgar Mitchell observed multiple light phenomena during their lunar stay. Mitchell, in particular, became convinced that the moon harbored unexplained phenomena, though his later public statements mixed scientific observations with more speculative claims. During Apollo 15, astronauts David Scott and James Irwin photographed what appeared to be light sources on the lunar surface, bright points that should not have existed if the moon were truly a dead world, illuminated only by the sunday during Apollo 16 and 17. Similar observations were made. The astronauts were professionals, trained observers, not given to fantasy. Yet they consistently reported seeing things that their training had not prepared them for. What were these lights? Some could be explained by reflections. The lunar surface contains glass beads formed by meteorite impacts, that melted surface material that could produce bright reflections under certain lighting conditions. A glass-rich area catching sunlight at the right angle might appear to glow. Some could be explained by temperature contrasts. In the harsh thermal environment of the moon, surfaces can reach extreme temperatures over 250 degrees Fahrenheit in sunlight, below minus 250 inches shadow. Objects at different temperatures emit different amounts of infrared radiation. While this is not visible to the naked eye, certain minerals might produce visible fluorescence when heated. Some could be explained by the transient lunar phenomena I mentioned earlier. Whatever causes those mysterious flashes could also have been active while the astronauts were present. But none of these explanations has been definitively linked to specific observations. The lights remain in the category of reported but unexplained phenomena that professional observers saw and documented, but that our science cannot fully account for. Now let me examine what the instruments detected. The Apollo missions did not rely solely on human observation. They deployed scientific instruments on the lunar surface: seismometers, magnetometers, heat flow experiments, laser reflectors. These instruments continued to operate for years after the astronauts departed, sending data back to Earth. What they detected was surprising. The seismometers revealed that the moon rings like a bell when the spent stages of the lunar module, or the S-4B rocket stages, were deliberately crashed into the moon to create seismic events. The vibrations continued for far longer than expected, sometimes over an hour. On Earth, seismic waves are quickly damped by the planet's layered structure. The moon apparently has a different internal structure that allows vibrations to persist. This long reverberation suggested that the moon might have cavities or unusual structures within it. The data were consistent with a highly fractured outer layer overlying a more rigid interior, but the exact nature of that interior remains debated. The magnetometers detected remnant magnetism in the lunar rocks, evidence that the moon once had a global magnetic field. This was surprising because the moon's core, if it exists, is small and should have cooled and solidified long ago, stopping any magnetic dynamo. Where did this ancient magnetism come from? The answer appears to be that the moon did have a dynamo in its early history, a molten core that generated a magnetic field for perhaps 1 billion years before cooling. The magnetic field is now gone, but its signature remains frozen in ancient rocks. But the magnetometers also detected something else: localized magnetic anomalies that did not fit the ancient dynamo model. Certain areas of the moon had magnetic signatures that were much stronger than the background, suggesting concentrations of magnetic material. What created these anomalies remained unclear. The heat flow experiments revealed that the moon is still warm, that heat is flowing from its interior to its surface at measurable rates. This was expected, as radioactive decay of elements in the lunar interior would produce heat, but the pattern of heat flow suggested that the moon's interior is more complex than simple models predicted. And there were anomalies in the data that were never fully explained, brief signals, unexplained readings, instrument behaviors that did not match expectations. These were generally attributed to equipment malfunctions or calibration errors. But they contributed to a picture of a moon that was stranger than anticipated. Now let me address what was photographed. The Apollo astronauts took thousands of photographs on the lunar surface. These images have been studied extensively, and most show exactly what we would expect: craters, rocks, equipment, astronauts, and the stark lunar landscape. But some images contain features that have generated controversy. In several photographs, there appear to be structures or shapes that look artificial geometric forms, linear features, arrangements that seem too regular to be natural. These images have fueled decades of speculation about lunar anomalies, alien artifacts, or secret NASA discoveries. Let me be direct. The vast majority of these claimed anomalies are optical illusions, photographic artifacts, or misinterpretations of natural features. The human brain is wired to see patterns, especially faces and structures, even where none exist. This phenomenon, called pareidolia, causes us to see familiar shapes in random formations. The lunar surface is covered with features that can look artificial under certain lighting conditions. Impact craters can appear circular and regular. Rock formations can cast shadows that suggest structure. Lens flares, processing artifacts, and scanning errors can create shapes in photographic images. I want to be clear that I am not endorsing conspiracy theories about artificial structures on the moon. The evidence does not support such claims, and responsible analysis must distinguish between genuine mysteries and manufactured ones. But there are legitimate photographic anomalies, features that are genuinely difficult to explain and that deserve scientific attention. Some photographs show unusual soil patterns, areas where the regolith appears to have been disturbed in ways that do not match astronaut activities. These could be artifacts of the photography, but some researchers have suggested they might indicate outgassing events or other surface processes. Some photographs show optical effects that are difficult to account for: glows, light distributions, and contrast patterns that do not match the expected behavior of light on an airless surface. These could be camera artifacts, but they have not all been definitively explained. Some photographs show objects in the sky, the Earth, stars, or bright points that cannot be immediately identified. Most of these have mundane explanations, but a few remain unexplained. The photographic record is vast, and it has not been exhaustively analyzed. What other anomalies might be waiting in the thousands of images that have not been closely examined? Now let me discuss the experiences the astronauts did not report publicly. In the decades since Apollo, some astronauts have spoken about experiences they did not report during their missions or in official debriefings. These accounts must be treated with caution. Memory is fallible, and the passage of decades can alter recollections, but they add texture to our understanding of what the astronauts encountered. Edgar Mitchell, the lunar module pilot of Apollo 14 and the sixth person to walk on the moon, became the most outspoken about unusual experiences. He described having a profound spiritual experience during his return journey, a sense of cosmic consciousness and interconnection that he later explored through research into consciousness and what he called the nature of reality. Mitchell also claimed in later years that NASA possessed evidence of extraterrestrial contact and that a cover-up existed. These claims were controversial and were not supported by other astronauts or by documentary evidence. But they reflected his conviction that the moon program had revealed truths that were not being shared with the public. Buzz Aldrin, the lunar module pilot of Apollo 11, has spoken about seeing a light moving alongside the spacecraft during the journey to the moon. He has described this object as probably a discarded panel from the spacecraft's launch configuration, tumbling in space and catching sunlight. But his descriptions have varied over the years, and some have interpreted his account as evidence of something more unusual. Other astronauts have been more circumspect, declining to discuss unusual experiences or insisting that they saw nothing beyond what was expected. This reticence is understandable. Astronauts are public figures whose credibility matters for their careers and for the space program. Speaking about unexplained phenomena risks being associated with fringe beliefs. But the private conversations among astronauts, as reported by those who knew them, suggest that the lunar experience was profound and sometimes disturbing. The isolation, the strangeness, the confrontation with a truly alien environment, these left marks that the astronauts carried for the rest of their lives. Now let me return to the question of what was already on the moon. I began this video by saying that something was already on the moon when Apollo 11 landed. Let me now be specific about what I mean. First, there was a dynamic environment that the astronauts did not expect. The moon they encountered was not the dead world they had prepared for. It was a world with dust that levitated, horizons that glowed, surfaces that produced strange smells, and rocks that contained frozen magnetism from an ancient era. It was a world where unexplained lights appeared and disappeared, where instruments detected signals they could not explain, where the landscape itself seemed to harbor secrets. This dynamic environment was already present. It did not arrive with the astronauts. Whatever processes caused the horizon glow, the transient lights, and the other anomalies were operating before humans arrived and continued after they left. The moon was not waiting passively to be explored. It was doing things even if we do not fully understand what. Second, there was evidence of a history far more complex than expected. The rocks the astronauts collected told stories of ancient volcanism, of a molten past, of a magnetic field that protected the moon before it died. They revealed that the moon had once been active geologically, magnetically, perhaps even in ways we do not yet recognize. This history was already written in the lunar regolith, waiting to be read. The astronauts did not create it, they discovered it. And the discovery revealed that our nearest neighbor had a past we had not imagined. Third, there was information about the Earth-Moon system that reshaped our understanding of our own planet. The moon, it turned out, is not just Earth's companion, it is Earth's sibling, born from a catastrophic collision early in solar system history. The rocks the astronauts brought back established this origin, revolutionizing our understanding of how planets form and evolve. This information was already present in the moon's composition, waiting to be extracted by careful analysis. The moon carried the record of Earth's violent birth, preserved for billions of years until humans arrived to read it. Fourth, and most mysteriously, there were phenomena that we still cannot explain. The transient lights, the unexplained signals, the observations that do not fit our models. These were already happening when the astronauts arrived, and they continue to this day. They represent genuine mysteries, not evidence of aliens, but evidence of our ignorance. The moon is not fully understood. Despite 6 crewed landings, despite decades of robotic exploration, despite the close attention of astronomers for centuries, the moon harbors secrets we have not penetrated. This is what was already on the moon when Apollo 11 landed, a world more complex, more dynamic, and more mysterious than we expected. Not alien artifacts, but something in some ways more profound evidence that even our nearest neighbor is stranger than we knew. In part 2, I want to explore what these mysteries tell us about the moon's nature, what subsequent missions have revealed, and what we might discover as the Artemis program returns humans to the lunar surface. So we've established what the Apollo astronauts encountered: the horizon glow, the transient lights, the strange dust, the unexplained phenomena that challenged their expectations of a dead and static world. We've seen that the moon they found was more dynamic, more mysterious, and more complex than anyone had anticipated. Now I want to explore what these mysteries tell us about the moon's true nature. What have we learned in the decades since Apollo? What explanations have emerged, and what remains genuinely unexplained? Let me begin with a phenomenon that has received the most scientific attention: the levitating lunar dust. The horizon glow that the astronauts photographed, that strange luminescence extending above the lunar surface at dawn and dusk, pointed towards something remarkable. Dust on the moon does not simply lie on the surface. It moves. It rises. It floats in ways that seem impossible on an airless world. On Earth, dust can be suspended in the atmosphere by wind, by thermal convection, by turbulence. None of these mechanisms exist on the moon. There is no air to carry particles, no weather to stir them, no medium through which they could float, and yet the dust floats. The mechanism, as best we understand it, is electrostatic levitation. The lunar surface is constantly bombarded by charged particles: the solar wind, ultraviolet radiation, cosmic rays. These impacts strip electrons from surface atoms, creating electrical charges. The dust particles themselves become charged, and when the charges become strong enough, they can overcome gravity. The physics is conceptually simple. Like charges repel, if enough dust particles carry the same charge, they will push away from each other and from the similarly charged surface. Given the moon's low gravity, 1/6 of Earth's, the forces required to lift a dust particle are small. A sufficiently charged particle could potentially rise meters, even kilometers, above the surface. But the details are anything but simple. The charging depends on the angle of sunlight, the composition of the surface, the energy of incoming particles, and the electrical conductivity of the regolith. Near the terminator, the line between day and night, the situation becomes especially complex. On the sunlit side, surfaces are positively charged. On the dark side, they become negatively charged. At the boundary, intense electric fields can develop. These fields could launch dust particles on ballistic trajectories, sending them arcing above the surface and back down. A steady rain of such particles, continuously lofted and falling, could create the horizon glow dust, catching sunlight at high altitude, producing the observed illumination. This mechanism was first proposed shortly after Apollo, and it has been refined by decades of theoretical work. But direct confirmation has been elusive. No mission has yet measured the electric fields at the terminator with sufficient precision to verify the model. No camera has captured individual particles in flight. The levitating dust remains theoretical, compelling, plausible, but not proven. The LADEE mission, Lunar Atmosphere and Dust Environment Explorer, launched in 2013 specifically to study these phenomena. It detected dust at high altitudes, consistent with levitation, but the measurements were indirect, and alternative explanations for the detected particles could not be ruled out. What LADEE did confirm is that the moon has an exosphere, a tenuous envelope of atoms and molecules extending above the surface. This exosphere is far too thin to be called an atmosphere, but it is not nothing. Atoms of sodium, potassium, helium, and argon have been detected, along with traces of other elements. Where do these atoms come from? Some are implanted by the solar wind. Some are released by meteorite impacts. Some may be outgassed from the lunar interior. This last source, outgassing, is particularly intriguing because it suggests that the moon's interior is not entirely dead. Now, let me explore what we know about the moon's interior. The Apollo seismometers operated for 8 years, recording thousands of moonquakes. The data they gathered revealed a moon far more complex than expected. The moon has a layered structure, broadly similar to Earth's. There is a crust thicker on the far side than the near side, composed of ancient, heavily cratered rock. Below the crust is a mantle of denser material, extending most of the way to the center. And at the center is a core, small, partially molten, and surprisingly dynamic. The moonquakes came in several types. Deep moonquakes originated hundreds of kilometers below the surface in the mantle. They occurred with a regular periodicity, correlated with the moon's orbital position. As the moon moved closer to and farther from Earth, tidal stresses flexed the interior and triggered seismic activity. This means the moon is not rigid. It flexes. It responds to gravitational forces. It has enough internal structure to accumulate and release stress in predictable patterns. Shallow moonquakes were rarer but more powerful. They occurred closer to the surface and were less predictable. Some may have been caused by thermal stresses as the surface heated and cooled through the lunar day-night cycle. Others may have had different causes, perhaps the settling of internal structures or the release of trapped gases. The most intriguing aspect of the seismic data was how the moon responded to impacts. When the spent stages of Apollo spacecraft were deliberately crashed into the surface, the resulting vibrations lasted far longer than expected, sometimes over an hour of measurable ringing. This prolonged reverberation suggested that the outer portion of the moon is highly fractured, broken into countless fragments that scatter and prolong seismic waves rather than damping them quickly. The moon's crust is essentially rubble, shattered by billions of years of impacts, loosely held together by gravity. But deeper inside, the structure is different. The mantle appears more solid, capable of transmitting seismic waves efficiently. And at the center, the small core may still contain liquid, a remnant of the moon's hotter past. This internal structure has implications for outgassing. If the moon's interior is not entirely solid, if there are liquid regions, or if volatile materials are trapped beneath the surface, then those materials could occasionally escape. Rising through fractures in the crust, they could reach the surface and be released into space. Such outgassing events could explain some of the transient phenomena the astronauts observed. A sudden release of gas might produce optical effects, scattering light, creating brief glows, even generating electrical discharges that could appear as flashes. Now, let me examine the evidence for ongoing lunar activity. For most of the 20th century, the scientific consensus held that the moon was geologically dead, that all volcanic and tectonic activity had ceased billions of years ago. The youngest volcanic features were thought to be at least 1 billion years old, perhaps older, but evidence has accumulated that challenges this view. In 2014, NASA's Lunar Reconnaissance Orbiter discovered features that appeared to be young volcanic deposits, dark, smooth areas on the lunar surface that showed few impact craters, suggesting recent formation. Recent in geological terms could mean as little as 50 to 100 million years ago, ancient by human standards, but remarkably young for the moon. These deposits, if correctly interpreted, suggest that volcanic activity continued far longer than previously thought. The moon may have experienced eruptions within the past few hundred million years, perhaps even more recently. More striking are the features called irregular mare patches, or IMPs. These are small, rough-textured areas found within the smooth mare regions, the ancient lava plains that cover much of the near side. The IMPs appear to be very young, perhaps only tens of millions of years old, possibly younger. What created the IMPs? One hypothesis is that they are the result of outgassing volcanic gases escaping through the old lava plains, disrupting the surface and creating the observed textures. If this is correct, the moon has been geologically active in the very recent past. Another line of evidence comes from the lunar atmosphere itself. The exosphere contains radon-222, a radioactive gas produced by the decay of uranium in rocks. Radon-222 has a half-life of only 3.8 days. Its presence in the exosphere means it must be continuously released from the surface. There is no way for ancient radon to persist. Where is this radon coming from? The most likely source is outgassing from the lunar interior. Uranium decays to radon deep in the crust or mantle. The radon works its way up through fractures and escapes into space. This process must be ongoing, a sign that the moon's interior is still releasing volatiles. The transient lunar phenomena, the mysterious flashes and glows observed by astronomers and astronauts, may be connected to this outgassing. When gas escapes from the interior, it could interact with the electrically charged surface environment, producing light. It could carry dust particles with it, creating localized clouds that scatter sunlight. It could trigger small-scale geological events visible from Earth or lunar orbit. This picture of the moon, a world with an active interior, ongoing outgassing, recent geological features, is very different from the dead world we imagined before Apollo. The moon is not frozen in time. It is evolving, changing, doing things. It may be doing them slowly, on timescales measured in millions of years, but it is not static. Now let me discuss the mysterious phenomenon of lunar flashes. Transient lunar phenomena, TLPs, have been reported for centuries. As early as 1178, a group of monks in Canterbury, England, reported seeing something dramatic happen to the moon, possibly an impact event. Since the invention of the telescope, astronomers have occasionally reported brief brightenings, color changes, or obscurations on the lunar surface. These reports were long regarded with skepticism. The observations were often made by single observers, were difficult to confirm, and could be attributed to atmospheric effects, optical illusions, or observer error. The scientific community largely dismissed TLPs as unreliable. But the Apollo observations changed this calculus. Professional astronauts, using calibrated equipment, with no atmosphere to confuse their observations, reported seeing flashes and lights on the lunar surface. Their testimony carried weight that amateur observations did not. Since Apollo, several systematic efforts have been made to observe and catalog TLPs. The most comprehensive study, conducted by NASA and other agencies, examined historical reports and attempted to correlate them with lunar features. The study found that TLP reports clustered around certain areas, particularly the crater Aristarchus, the Plato region, and the edges of the Maria. This clustering is significant. If TLPs were purely observational artifacts, they should be randomly distributed across the lunar surface. The fact that they cluster suggests that something real is happening in specific locations. Something about those locations produces transient events that can be observed from Earth. What might these locations have in common? Some researchers have noted that TLP hotspots tend to be associated with mare boundaries, with young geological features, or with areas of known outgassing. This supports the hypothesis that TLPs are related to interior activity, gas releases, volcanic residual heat, or seismic events disturbing the surface. In recent years, automated monitoring programs have attempted to catch TLPs in real time. These programs use multiple telescopes to observe the moon simultaneously, hoping to capture events that can be confirmed by independent observers. Some successes have been reported, but the events remain rare and difficult to study. What have these programs detected? Mostly, they have caught impact flashes, the brief brightenings produced when meteorites strike the lunar surface. These impacts occur regularly. The moon, lacking an atmosphere to burn up incoming material, is constantly bombarded by small bodies. Impact flashes can be bright enough to see from Earth, and they have been captured on video numerous times. But not all observed flashes can be attributed to impacts. Some have characteristics inconsistent with impact physics: wrong duration, wrong color, wrong location. These unexplained events remain in the TLP category, mysteries awaiting explanation. Now let me explore what we've learned about lunar water. One of the most significant discoveries since Apollo has been the confirmation that the moon is not entirely dry. Water exists on the moon, not much, not in liquid form, but present in forms that could be scientifically and practically significant. The first hints came from spacecraft observations in the 1990s. The Clementine and Lunar Prospector missions detected signatures consistent with water ice in permanently shadowed craters near the lunar poles. These regions, which never receive direct sunlight, are among the coldest places in the solar system, cold enough to trap and preserve water ice for billions of years. But the extent and nature of this water remained uncertain. The signals could be interpreted in multiple ways, and direct confirmation was lacking. In 2009, NASA's L-Cross mission provided dramatic confirmation. A spent rocket stage was deliberately crashed into a permanently shadowed crater near the South Pole. Instruments observed the resulting debris plume and detected clear signatures of water along with other volatiles including methane, ammonia, and carbon dioxide. There was water on the moon. Not much the estimates suggested concentrations of a few percent by weight in the affected area, but definitively present. Subsequent observations have refined this picture. The Lunar Reconnaissance Orbiter has mapped hydrogen concentrations across the poles, revealing where water ice is most likely to exist. India's Chandrayaan-1 mission detected water molecules on the sunlit surface, not just in polar shadows, but across the moon. This sunlit water is different from the polar ice. It appears to be water molecules bound to the lunar soil, constantly being created by the interaction of solar, wind, hydrogen with oxygen in surface minerals. This water is not stable. It is created and destroyed on short timescales, forming a dynamic system that cycles water through the surface. Where did the polar ice come from? Multiple sources are possible. Comets and water-rich asteroids have bombarded the moon for billions of years, delivering water that could be trapped in cold regions. Volcanic outgassing from the lunar interior could have released water vapor that migrated to the poles. Even the solar wind process that creates surface water could contribute molecules that eventually find their way to permanent shadows. This water is significant not just scientifically, but practically. Water is essential for human survival. It can be split into hydrogen and oxygen for rocket fuel. If lunar water can be extracted and utilized, it could dramatically reduce the cost of space exploration, turning the moon from a destination into a resource. The Artemis program is targeting the lunar South Pole precisely because of this water. The goal is not just to explore, but to utilize, to demonstrate that lunar resources can support human presence. But the water also raises questions. If the moon has been accumulating water in polar shadows for billions of years, what else might be trapped there? What record of solar system history is preserved in those ancient ices? What might we learn from material that has been cold trapped since the moon formed? Now, let me discuss what future exploration might reveal. The Artemis program aims to return humans to the moon for the first time since 1972. As of now, astronauts are in lunar space aboard Artemis 2, testing the systems that will enable future surface missions. If the program proceeds as planned, astronauts will walk on the moon again before the end of this decade. These new missions will carry vastly more capable instruments than Apollo did. Modern seismometers can detect fainter events and locate them more precisely. Spectrometers can identify materials with greater sensitivity and resolution. Cameras can image at higher resolution across more wavelengths. What might these instruments reveal? First, they could solve the mystery of the horizon glow. Direct measurement of electric fields at the terminator could confirm or refute the dust levitation hypothesis. Cameras designed to image particles against the dark sky could capture dust in flight. If levitation is occurring, the next generation of instruments should be able to prove it and measure its extent, its variation, and its causes. Second, they could investigate transient lunar phenomena. Instruments deployed on the surface could monitor for TLPs continuously, recording any events that occur. Seismometers could detect if TLPs correlate with moonquakes. Gas detectors could identify if TLPs coincide with outgassing events. With enough data, the cause of these mysterious flashes might finally be determined. Third, they could probe the lunar interior. A network of seismometers deployed at multiple sites could map the moon's internal structure with unprecedented precision. This could reveal whether liquid regions persist in the core, whether magma pockets exist in the mantle, and whether the internal activity suggested by recent features is ongoing. Fourth, they could explore the polar regions. The Artemis landings are targeting the lunar South Pole, where permanently shadowed craters may contain ancient water ice. Sampling this ice, analyzing its composition, measuring its age, studying its structure could reveal the history of volatiles in the inner solar system. What other secrets might these regions hold? No one knows. The permanently shadowed areas have never been explored directly. They may contain surprises we cannot anticipate. Fifth, they could investigate the far side of the moon, the hemisphere that never faces Earth, remains largely unexplored by humans. China has landed robotic missions there, but no astronaut has ever set foot on far side terrain. The far side is different from the near side. It has fewer maria, the dark lava plains that dominate the near side, and more heavily cratered highlands. Its crust is thicker. Its geological history may have been different. Why the asymmetry? We do not fully understand. Exploring the far side could reveal why the moon's two hemispheres evolved so differently, illuminating the processes that shaped our satellite. Now let me return to the central question. What was already on the moon? The title of this video asks about something that was already present when Apollo 11 landed. I've discussed phenomena, the horizon glow, the transient lights, the dynamic dust, the evidence of interior activity. These were all present before humans arrived and continue to be present today. But I want to address a deeper question. What does it mean that the moon is not what we expected? Before Apollo, the moon was a symbol of desolation, a dead world, a contrast to the vibrant Earth, a place where nothing happened. This conception shaped how we thought about the moon, how we planned missions, and how we interpreted observations. Apollo revealed that this conception was wrong. The moon is not dead. It is quiescent, quiet, slow, subtle, but not dead. Processes are occurring there that we do not fully understand. The moon is not simply a museum of ancient history. It is a world with its own ongoing story. This has implications beyond the moon itself. If the moon, our nearest neighbor, the world we have studied most closely, still harbors mysteries, what about other worlds? What processes might be occurring on Mercury, on the asteroids, on the moons of the outer planets? Our expectations of what dead worlds should be like may be systematically wrong. The solar system may be more dynamic than we imagined. Worlds we have dismissed as geologically inactive may have their own subtle processes, their own mysteries, their own phenomena that challenge our assumptions. And if this is true within our solar system, what about beyond? The exoplanets we are discovering around other stars, how wrong might our assumptions about them be? How much are we missing because we do not know what to look for? The moon teaches humility. It teaches that even familiar objects can surprise us, that decades of observation do not exhaust the mysteries of a world, that the universe is always stranger than we expect. What was already on the moon when Apollo 11 landed? A world more complex than we knew, a world with processes we did not anticipate, a world that, after 50 years of study, we still do not fully understand. And that world is waiting for us to return. In part 3, I want to explore the deepest mysteries that remain, the questions that even our best science cannot yet answer, and what they might tell us about the nature of the moon, its history, and its relationship to Earth and the broader cosmos. So we've established what the Apollo astronauts encountered and explored what subsequent research has revealed about the moon's dynamic nature. We've seen that the moon is not the dead world we imagined, that it has ongoing processes, unexplained phenomena, and mysteries that decades of study have not resolved. Now I want to explore the deepest questions that remain. What do these mysteries tell us about the moon's origin and history? What is the relationship between the moon and Earth? And what might we discover as humanity returns to explore our nearest neighbor in space? Let me begin with the most fundamental question. Where did the moon come from? The origin of the moon is one of the great stories of planetary science, a story that the Apollo missions helped to write, and one that continues to evolve as new evidence emerges. Before Apollo, several hypotheses competed to explain the moon's existence. The fission hypothesis proposed that the moon spun off from a rapidly rotating early Earth, that our planet once rotated so fast that a piece of it flew off and became a separate body. This idea had elegance but faced serious physical problems. The angular momentum required was difficult to achieve, and the mechanism for ejecting a moon-sized mass was unclear. The capture hypothesis proposed that the moon formed elsewhere in the solar system and was later captured by Earth's gravity. Moons of the outer planets may have formed this way, but capture is dynamically difficult. The moon would have needed to lose precisely the right amount of energy to be captured into a stable orbit rather than flying past or crashing into Earth. The co-accretion hypothesis proposed that the Earth and moon formed together from the same cloud of material as a double planet. This would explain their orbital relationship, but struggled to account for differences in their compositions. None of these hypotheses was entirely satisfactory. The moon's origin remained a puzzle. Apollo changed this. The rocks the astronauts brought back provided crucial data about the moon's composition, its age, and its relationship to Earth. What they revealed was startling. The moon's composition was similar to Earth's, remarkably similar. The isotopic ratios of oxygen, titanium, and other elements matched those of Earth to a degree that seemed impossible if the moon had formed elsewhere in the solar system. The moon appeared to be made of the same stuff as Earth, but the moon was also different. It had much less iron than Earth, and virtually no volatile elements, no water, no carbon, no easily evaporated materials. It was as if someone had taken Earth material, heated it intensely to drive off the volatiles, and kept only the rocky residue. These observations pointed toward a new hypothesis, one so dramatic that it took years to gain acceptance. The giant impact hypothesis proposes that the moon was born in violence, created when a Mars-sized body collided with the early Earth approximately 4.5 billion years ago. In this scenario, the impactor, sometimes called Theia, struck the young Earth at a glancing angle. The collision was catastrophic. Both bodies were largely destroyed, their interiors melting and mixing, their materials spraying into space. Some of this material fell back onto Earth, contributing to our planet's mass. But some went into orbit around Earth, forming a disk of hot debris that gradually coalesced into the moon. This hypothesis explained the observations beautifully. The moon's composition matches Earth's because the moon is made largely of Earth material rock, vaporized by the impact, blown into space, and reassembled into a new body. The moon lacks iron because the impactor's iron core merged with Earth's core rather than being ejected into orbit. The moon lacks volatiles because the material was heated so intensely that volatiles escaped to space. The giant impact hypothesis became the consensus explanation for the moon's origin. But like all scientific theories, it faces challenges and continues to evolve. Now let me examine the problems with the giant impact hypothesis. The basic scenario explains many observations, but detailed analysis reveals difficulties. The first problem is the isotopic similarity. If the moon formed from a mix of Earth and Theia material, it should have a composition intermediate between the two. But isotopic measurements show that Earth and Moon are essentially identical, far more similar than they should be if a foreign body contributed half the Moon's mass. Where is the Theia signature? Why doesn't the Moon show evidence of its other parent? Several solutions have been proposed. Perhaps Theia formed near Earth and happened to have the same isotopic composition. Perhaps the impact was so violent that both bodies were completely vaporized and thoroughly mixed, erasing any isotopic difference. Perhaps some process we don't understand homogenized the compositions after the impact. None of these solutions is entirely satisfactory. The isotopic sameness remains a puzzle. The second problem is the angular momentum. The Earth-Moon system has a certain amount of angular momentum, a measure of how much rotational motion is present. The giant impact should have imparted a specific amount of angular momentum that we can calculate, but the calculations don't quite work. Some versions of the impact produce too much angular momentum, others produce too little. The observed angular momentum is difficult to explain with a simple impact scenario. Modifications to the hypothesis attempt to address this. Perhaps tidal interactions with the Sun bled off angular momentum after the Moon formed. Perhaps the impact geometry was different than typically assumed. The angular momentum problem is not fatal to the hypothesis, but it requires explanation. The third problem is the Moon's orbit. The Moon's orbit is tilted about 5 degrees relative to the plane of Earth's orbit around the Sunday. This tilt is difficult to explain if the Moon formed from a debris disk around Earth, which should have been aligned with Earth's equator. Some process must have tilted the Moon's orbit after formation. Gravitational interactions with the Sun, with other planets, or with debris left over from the impact might have done this, but the details remain unclear. The fourth problem is what we're still learning. New measurements continue to challenge the simple impact scenario. Recent studies have found subtle isotopic differences between Earth and Moon, in certain elements differences that might contain information about the impact, but that current models do not fully explain. The giant impact hypothesis is almost certainly correct in its broad outlines. Something massive hit the early Earth, and the Moon was born from the collision, but the details, exactly what hit, exactly how, exactly what happened afterward, remain subjects of active research. This is the nature of science. Even our best theories are provisional, subject to revision as new evidence emerges. The Moon's origin story continues to be written. Now let me explore what the Moon tells us about Earth's early history. The Moon is more than just Earth's companion. It is a witness to Earth's past, a recorder of events that our own planet has forgotten. Earth is geologically active. Plate tectonics constantly resurface our planet, dragging old crust into the mantle, and creating new crust at spreading ridges. Erosion by wind and water wears down surfaces, while volcanic activity buries old terrain under new material. The geological record, older than about 4 billion years, has been almost entirely erased. The moon lacks these processes. Without plate tectonics, without wind, without water, the lunar surface preserves a record stretching back to the moon's formation. Craters from ancient impacts remain visible. Rocks from the earliest epochs lie on the surface, accessible to collection. This makes the moon an archive, a library of early solar system history that Earth has lost. The Apollo samples revealed crucial chapters of this history. They established the age of the moon with precision, approximately 4.5 billion years, formed in the aftermath of the giant impact. They documented the intense bombardment that the early moon and Earth experienced, with massive impacts continuing until about 3.8 billion years ago. They recorded ancient magnetic fields, volcanic activity, and chemical processes that shaped the young moon. Some of these findings have direct relevance to Earth. The late heavy bombardment, a period of intense impact activity around 3.8 to 4.1 billion years ago, left its signature on the moon in the form of large impact basins and widespread debris. The same bombardment must have struck Earth, though the evidence has been erased from our planet's surface. What caused the late heavy bombardment? The leading hypothesis involves the migration of the giant planets. Jupiter and Saturn, shifting in their orbits, gravitationally scattered asteroids and comets throughout the inner solar system. The Moon and Earth received the brunt of this bombardment, with impacts large enough to sterilize oceans and reshape continents. This has implications for the origin of life. Life on Earth appears to have emerged around 3.8 billion years ago, shortly after the bombardment ended. Was this a coincidence, or did the bombardment play a role? Perhaps life arose multiple times during the bombardment, only to be extinguished by massive impacts. Perhaps the bombardment delivered materials, water, organic molecules that were necessary for life. Perhaps the subsiding impacts created environments where life could finally gain a foothold. The moon preserves the record of this violent era. By studying lunar samples, we can reconstruct the timing and intensity of the bombardment, learning about the conditions that prevailed when life on Earth began. Now let me consider what the moon might tell us about life itself. This is a speculative area, but one worth exploring. Could the moon harbor evidence relevant to the origin of life? Consider the polar ice deposits. These permanently shadowed regions have been cold-trapping volatiles for billions of years. Water, carbon dioxide, ammonia, methane materials delivered by comets and asteroids may be preserved in these ices. These are the same materials that are thought to be building blocks for life. The comets that delivered water to the moon also delivered organic molecules, the same organics that may have contributed to the chemistry of early Earth. If these materials are preserved in lunar ice, they represent a sample of the early solar system's volatile inventory. Analyzing them could reveal what organic compounds were available when life was forming both on Earth and potentially elsewhere. More speculatively, some researchers have proposed that fragments of early Earth might be preserved on the moon. During the late heavy bombardment, massive impacts on Earth would have ejected material into space. Some of this material could have reached the moon and been preserved on its surface. If rocks from the early Earth, including rocks that might contain chemical or even biological signatures, survive this journey and remain on the moon, they could provide direct evidence of conditions on our planet before the geological record begins. This is a long shot. The ejected material would have experienced extreme heating. Any biological signatures would likely be destroyed. But the possibility exists, and it motivates careful study of lunar samples. The moon could also serve as a test bed for understanding how life might survive in extreme environments. The lunar surface is bombarded by radiation, experiences extreme temperature swings, and lacks atmosphere and liquid water. Yet certain organisms, bacterial spores, tardigrades, some fungi can survive remarkably harsh conditions. Understanding what survives on the moon, what we might inadvertently bring there, what might endure, has implications for the search for life elsewhere. The moon is a natural laboratory for studying extremophile survival, relevant to questions about life on Mars, on icy moons, and on exoplanets. Now let me return to the unexplained phenomena and ask what they might ultimately mean. I have discussed the horizon glow, the transient lunar phenomena, the unexplained lights, the anomalous observations. I have presented the leading scientific explanations, levitating dust, outgassing, impact flashes, and so on. These explanations are plausible and likely account for most of what has been observed. But I want to be honest about the limits of our understanding. Some phenomena remain genuinely unexplained. Not everything fits neatly into our models. Some observations resist easy categorization. What should we make of this? One response is to dismiss the unexplained observations as errors, misperceptions, equipment malfunctions, wishful thinking. This response has merit. Human observation is fallible. Instruments can produce artifacts. Not every report reflects reality, but this response can also be too easy. Dismissing observations because they don't fit our models is not science, it is dogma. The history of science is full of cases where anomalous observations initially dismissed turned out to be real and important. Another response is to embrace the mystery, to conclude that the moon harbors phenomena that current science cannot explain, perhaps phenomena that are fundamentally new. This response also has merit. Science advances by confronting what it cannot explain. Every major discovery began as an anomaly, an observation that didn't fit, a puzzle that demanded new thinking. The unexplained phenomena on the moon might be pointing toward discoveries we have not yet made. But this response can also go too far. Not every unexplained observation represents a new discovery. Sometimes things are unexplained simply because we lack data, not because they require new physics. The appropriate response, I believe, is careful attention. We should neither dismiss the unexplained phenomena nor overinterpret them. We should document them carefully, study them systematically, and remain open to whatever they might reveal. This is what the Artemis program offers: an opportunity to investigate these mysteries with modern instruments, trained observers, and extended presence on the lunar surface. Some mysteries may be solved quickly, others may deepen, but either way, we will learn. Now let me explore what the moon means for humanity's future. The moon has been a symbol throughout human history, a marker of time, a source of light, a presence in mythology and culture. But the moon is about to become something more: a destination, a resource, a stepping stone. The Artemis program aims to establish sustainable human presence on the moon. Not just visits, but infrastructure. Not just exploration, but utilization. The goal is a base camp from which humans can live and work, supported by local resources, enabling missions deeper into the solar system. This is a fundamentally different relationship with the moon than Apollo represented. Apollo was a sprint, a race to demonstrate capability, followed by departure. Artemis aspires to be a marathon, a sustained effort to make the moon accessible and useful. What would sustainable lunar presence look like? First, it requires resource utilization. Bringing everything from Earth is prohibitively expensive. If lunar water can be extracted from polar ice, it can provide drinking water, breathable oxygen, and rocket propellant. If lunar regolith can be processed for metals, it can provide construction materials. The moon must supply what the moon needs. Second, it requires infrastructure. Power systems, probably solar, possibly nuclear, must operate continuously. Habitats must protect inhabitants from radiation, temperature extremes, and micrometeorite impacts. Communication systems must maintain contact with Earth. Transportation systems must move people and materials across the surface. Third, it requires economic justification. Governments can fund exploration for scientific and strategic reasons, but sustained presence may require economic returns. What can the moon provide that justifies the investment? Potential answers include lunar resources, helium, 3 for fusion power, rare metals for electronics, water for space operations. They include services, scientific research, astronomy from the far side, manufacturing in low gravity. They include strategic value, maintaining presence in a domain that other nations are also pursuing. Whether these justifications will prove sufficient remains to be seen. The economic case for lunar development is speculative, dependent on technology that does not yet exist and markets that have not yet formed. But the effort is underway. Multiple nations, the United States, China, India, Japan, European countries, are pursuing lunar programs. Private companies, SpaceX, Blue Origin, and others are developing lunar capabilities. The moon is becoming a destination for humanity, not just for individual missions. Now let me consider what this means for our understanding of the cosmos. The moon is not just interesting for itself. It is a window onto the larger universe. From the lunar surface, the sky is different. Without atmosphere to scatter light, stars do not twinkle. They appear as steady points in a black sky, visible even when the sun is above the horizon. The band of the Milky Way stretches across the darkness with a clarity impossible from Earth. The lunar far side offers something unique: radio silence. Earth is noisy, and the radio spectrum transmissions from billions of devices create a constant electromagnetic background. This noise makes it difficult to detect faint signals from the cosmos, but the far side of the moon is shielded from Earth by the bulk of the moon itself. It is the quietest place in the inner solar system for radio astronomy. A telescope there could detect signals that are impossible to observe, from Earth signals from the cosmic dark ages, the epoch before the first stars formed, when the universe was filled with neutral hydrogen that has left its imprint in radio waves. This radio silence might also be relevant to the search for extraterrestrial intelligence. If other civilizations are transmitting signals, a far-side telescope might detect them more easily than any Earth-based observatory. The moon also offers a platform for other kinds of astronomy. Without atmosphere, observations can be made at wavelengths, ultraviolet, infrared, X-ray, that Earth's atmosphere blocks. Without seismic noise, gravitational wave detectors might achieve greater sensitivity. Without light pollution, optical telescopes can observe fainter objects. The moon could become humanity's greatest observatory, a platform for studying the universe with capabilities impossible on Earth. Now, let me reflect on what it means that something was already on the moon. I began this exploration by saying that something was present on the moon when Apollo 11 landed. I have discussed the phenomena the astronauts encountered, the scientific mysteries that remain, and the broader questions about the moon's nature and history. Let me now summarize what I believe was already there. First, there was a world with a violent past. The moon was born in catastrophe created by an impact that nearly destroyed the Earth. It carries the scars of billions of years of bombardment, a record of the solar system's violent youth. This history was written in the rocks the astronauts collected, waiting to be read. Second, there was a world with ongoing processes. The moon is not dead. Dust levitates above its surface. Gases escape from its interior. Seismic events shake its structure. Mysterious lights appear and disappear. These processes were occurring before humans arrived and continue today. Third, there was a world with resources: water, ice in polar shadows, metals in ancient rocks, helium 3 inches, the regolith materials that could support human presence and enable deeper exploration. These resources were deposited over billions of years, preserved by the moon's stillness awaiting discovery. Fourth, there was a world with secrets, transient phenomena we cannot explain, anomalous observations that resist interpretation, a surface that has been studied for centuries yet still surprises us. These secrets remain, challenging our assumptions and inviting further investigation. Fifth, there was a world that holds a mirror to Earth. The moon's origin is entangled with Earth's. Its history illuminates our own. Its surface preserves records that Earth has lost. In studying the moon, we learn about ourselves, about our planet's past, about the conditions that allowed life to arise, about the cosmic context of our existence. This is what was already on the moon when Apollo 11 landed. Not aliens, not artifacts, not the fantasies of conspiracy theories, but something in some ways more profound. A world with a story, a world with processes, a world with mysteries that connect to the deepest questions we can ask. The astronauts saw it. They saw the horizon glow, the strange dust, the unexpected phenomena. They brought back rocks that revolutionized our understanding. They reported observations that we still cannot fully explain, and now we are returning. The Artemis program will send new astronauts to the moon, equipped with instruments far more capable than Apollo carried. They will investigate the mysteries that remain. They will explore regions never visited by humans. They will begin the work of making the moon accessible to humanity. What will they find? What secrets remain to be uncovered? What surprises await us on a world we have studied for centuries but still do not fully understand? The astronauts saw something when they landed on the moon. They saw a world stranger than expected, more dynamic than assumed, more mysterious than we knew. We are about to see it again. And this time, we are staying. The moon has been waiting for 4.5 billion years. It has witnessed the birth of the Earth, the emergence of life, the rise of intelligence. It has recorded cosmic history in its rocks and craters. It has harbored processes and phenomena that we are only beginning to understand. Now humanity is returning. We are bringing our questions, our instruments, our curiosity. We are bringing our determination to understand what is already there and our ambition to make it part of our future. Something was already on the moon when Apollo 11 landed. The astronauts saw it, documented it, brought pieces of it home, but they only scratched the surface of what the moon contains. The next chapter is about to begin. What will we discover? What will we learn? What will we find that we cannot yet imagine? The moon awaits, its secrets are patient, and we are finally ready to uncover them.